All right, we are continuing with probability. This is question 9. On a flight, passengers could choose between vegetarian snake and a chicken snake. The snakes selected by the passengers were recorded. The results are shown in the table below. We have two types of snakes there, vegetarian or chicken. So we have two choices. And then for the passengers, we have males and then we have females. And we have a total of 150, that is 67 males and 83 females. That gives us 150. Now the question is saying, was the choice of snake on this flight independent of gender? Motivate your answer with necessary calculations, and this is 5 marks. All right. So we are saying here, probably if you are choosing vegetarian snake, is it being affected by you being a male or being a female? Or choosing chicken, is it being affected by you being a male or you being a female? Or these two do not affect each other, that is, they are independent of each other. So to show that, the first thing you have to remember the equation for independent events. We have two here. Let me choose probably a vegetarian, choosing a vegetarian and being a male. You could say choosing a vegetarian and being a female. You could also use chicken and being a male, or chicken and being a female, any one of those four. But I'm going to choose being a vegetarian and being a male and choosing vegetarian. We want to see whether those two are independent of each other. So my probabilities there is V and M. So I am saying for independent events, probability of V and M should be equal to probability of V times probability of M. This is the probability equation for independent events. So we are going to treat this like an identity. We deal with the left-hand side, and then we deal with the right-hand side separately. And then at the end, we compare. If the answers are equal, then that means they are independent. But if the results are not equal, then that means they are not independent events. All right. Now, the first one here, let me write this side, probability of V, that is probability of choosing vegetarian, that is going to be equal to, is total for vegetarian is 32 out of 150, so it's 32 over 150, and probability of being a male, total of 67 males out of 150, so this is 67 over 150. Now we have the two, and then probability of choosing vegetarian while being a man, we need to get it from the diagram there. Probability of choosing a vegetarian while being a male is only 12, so this is probability of V and M. This is 12 over 150. That is from the diagram. And remember, we are going to compare the two. So let's just give it as a decimal. As a decimal, we are going to get, it should be 0.08. 0.08. And then the second one, probability of V times probability of male is equal to, we are multiplying these two, that is 32 over 150 times 67 over 150, and this should give us on the calculator 0.08. 0.095. There we are. So we have 0.08 and 0.095. So what does this tell us? We can see that probability of V and M, that is the probability of choosing vegetarian while being male, is not equal to the probability of vegetarian times the probability of male. These are not equal, so we can conclude they are not independent, because this should be the equation for independent events. If the left hand side was equal to the right hand side, then we could conclude that they are independent. But now, because the left hand side is not equal to the right hand side, then we can say they are not, it's not independent of gender. All right. The second question: for any two events A and B, it is given that probability of A and B is equal to 0.12, probability of A or B is equal to 0.83, and then probability of B is 4 times the probability of A. The first question: are the events mutually exclusive? Justify your answer. When you look at mutually exclusive events, remember, mutually exclusive events, if we have event A and event B, your probability of A and B should be equal to 0. That is mutually exclusive events. This is intersection. So mutually exclusive events are those events which do not have an intersection. That's why we are saying mutually exclusive events, probability of A and B should be equal to 0. Right? Now, how do we show that the events are not mutually exclusive? We have been given here probability of, there we are. This is our answer there. We said for them to be mutually exclusive, probability of A and B should be equal to 0. But in this case, we are told that it's actually equal to 0.12, right? So from there, we can say the events are not mutually exclusive, right? Because they are not equal to 0. They were going to be mutually exclusive if they were equal to 0. But in this case, probability of A and B is equal to that and not equal to 0. So they are not mutually exclusive. Then the second question: calculate the probability of B. How do I calculate the probability of B? Let me use what is given there. You remember the equation for probability. We have probability of A or B is equal to probability of A plus probability of B minus probability of A and B, that is the intersection there. Now, I've been given the probability of A or B is 0.83, so this is 0.83 is equal to, do I have probability of A? I do not have probability of A, so I'm saying probability of A. Probability of B, do I have? I've been given here the relationship between probability of A and probability of B. So in place of probability of B, I'm writing plus 4 probability of A minus, we do have probability of A and B there, that is 0.12. And then we have an equation now. We can take this to the left. We have 0.83 plus 0.12 is equal to, I've taken this to the left, and then this is 1 probability of A plus 4 probability of A. Put them together, we get 5 probability of A. Now, to get probability of A now, it's equal to divide both sides by 5. So this one is going to be equal to 0, 0.95. 0.95, and then divide both sides by 5, and this is going to be equal to 1 with a 4, 9, so this is 0.19. Probability of A is equal to 0.19, but we want probability of B, and here we have been told that probability of B is equal to probability of A times 4. So we are saying here probability of B is equal to probability of A multiplied by 4. So 0.19 multiplied by 4. 0.40 plus 0.36. So this is equal to 0.76. That is the probability of B. And then the last question, calculate probability of not A. Probability of not A is equal to 1 minus probability of A. So this is equal to 1 minus 0, probability of A is 0.19. So this should be equal to 20, and then it's 81, 0.81. All right, that's all for this question.